Hello learners, welcome to the last week of the course on science communication, research productivity and data analytics using open source software. In this week, we are going to delve into some of the case studies that illustrate the concept we have discussed throughout the course. We will be discussing the case studies on a domain, then an author, a journal and an institution. Throughout the course, we have discussed the analysis in R from the source side. We have seen how different analyses can be performed using various packages and their functions. The key idea following this approach was to get you familiar with R in case if you want to do any other analysis for which any package or function is not available, then you can easily do that. However, in R, some of the packages like bibliometrics have the function biblioshiny, which provides you web-based interface for the analysis, where you don't have to focus on much of the functions and it's a menu-driven software. So, for doing the analysis, you have to just select the option and the analysis is done. So, while discussing case studies in this week, we will be following a two-way approach. So, the first we will discuss the case study using the source side and then we will discuss the other case studies using the biblioshiny interface. So, let's start the first case study. So, in the first case study, we are aiming to map the research on application of AI in tourism. So, what we aim to do it, we want to map the AI research in tourism. And our objective for this particular case study is that we want to do the annual publication productivity, then yearly citations, then prolific sources, means what are the sources are there which have published more on this particular area. Then we will do the authorship analysis and in the finally we will see the core sources, what are the core sources on this area. So, to do this particular case study, what we need to do? So, as a very first step, we need to select the data source. Okay. So, step 1 is we need to select the data source. So, there are like different kind of data sources are available, like we have already discussed about. There is a Scopus is there, then Web of Science is there, PubMed is there, then Google Scholar is there. But for this particular case study, we will be taking an example of Scopus. Okay. So, then at the second step, what we need to do? We need to do select the terms, okay, based on which we will search this particular database. Okay. So, at step 2, we need to select the terms. Then at the third step, we need to select that where exactly we will search these particular terms in that database. Okay. So, at step 3, so we have already seen in these databases, like there are different options are there. Either we can search on title, then on abstract or keywords. Okay. So, we need to decide that these selected terms are to be searched in either title, abstract or keywords, or maybe combination of these fields, like maybe title or abstract, or maybe abstract or keywords, or maybe title, abstract or keywords, all three. Okay. So, after implementing the step 3, it will give number of results. Okay. So, at step 4, we will give the some conditions based on which we will filtering the data. Okay. So, at step 4, filtration of data. So, what exactly this step 4 is? So, like say for example, you want to limit the data by either with the language side, okay, maybe language English, okay, or maybe the year, like from starting year like 1960 to maybe 1990, okay. Then we may want to filter the results with the like publication stage. So some of the articles maybe are not published, so we maybe move to the publication stage. Then we may want to filter the data based on the document type. Okay, so we can have the document type conference, paper, article, review paper, editorial, okay, notes, data paper, and so on. Okay, so among these category we may want to restrict our data either to the conference or maybe article or maybe to the review papers. Okay, then we may also have the like filtration of like based on the open access documents. So under the open access we may restrict the data either by the green open access or the gold open access. So like this way we filter the data. Okay, and at step 5 we extract the data. Okay, so we extract this data in appropriate format. Okay, so what are the format we require, like Scopus provides CSV, BIB. Okay, so we may want to have the data in maybe either the BIP format, CSV, or other format what Scopus provides. So we can extract the data. And in the last step after extraction of data we do the analysis. Okay, so for doing the analysis we select the software. So what all software we will be using, like R we will be using, or maybe WOS viewer we will be using for visualization. Okay, so this is how we do the analysis of research productivity. Okay, so in this particular case study we are going with the Scopus database. So our step 1 is done. So we'll go to the second step. So what exactly second step is? So selection of the term is an another important step in doing the assessment of the research productivity, because we are selecting the terms that represent particular area. Okay, so if you miss any of the terms that represent that particular area or a subject, you won't be getting the comprehensive results about that area. Okay, so for doing that, it's a good practice that you should select maximum number of words that represent that particular area. Okay, so for selection of term we follow different approaches. Some of the approaches are listed on this slide. So first we may review the preliminary literature, like literature on related to that topic, or maybe we can consult with the librarians or the expert on that area. Then we can follow the control vocabulary and thesaurus. There are like different vocabularies are available, like mesh is available for medical subject heading. Okay, then one can also review the related research published, like say for example somebody has done this kind of assessment on artificial intelligence, and somebody has done the research on this tourism. Okay, so what example we are taking for this case study? Okay, so what exactly the terms selected by those authors for doing the research on artificial intelligence, and what exactly the terms are selected by those authors for doing the research on tourism. Okay, so we can review those research and then we can select our terms. Okay, and this is a iterated process. Okay, so we go on searching with the terms, then we found some other terms in keywords, and then we refine our terms for our final searches on that particular databases. Okay, so we need to do this step multiple times so that we get the good idea about that particular area. Okay, so as an example, what I am taking up is that somebody has done the research on application of AI, and I have taken up the some terms from there, and then I have taken up some researches which have done on tourism. Okay, so if you see here in this paper, the author have used the terms artificial intelligence and AI, because somebody may have published the paper by mentioning only AI. Okay, or maybe the artificial intelligence. If you see in the second example, the authors have used the terms artificial intelligence, then machine intelligence, machine learning, deep learning, and deep network. Okay, so these are also the terms. Then in this, if you see the example here, in this particular example, they have taken more number of words. Okay, so what exactly the number of words are there? So artificial intelligence is there, computational intelligence is there, machine learning, deep learning, decision trees, then expert system, neural network, voice recognition, text mining, electronic health records, and then because this was the research related to health, so they have taken this word also. But if you see in these three example, the first example there were only two words. Okay, then there are, like in second example there are five words, and in the third example there are more number of words are there. And in the fourth example, if you see here, so in second and third example they don't have used AI. Okay, so they might have missed some documents. Okay, but if you see in the fourth example, they have used the word AI, artificial intelligence, then neural network, text mining, natural language processing, and other things are similar to the this example. Okay, and if you see in the fifth example, here also they have used similar kind of words. Okay, but only two of the paper from these five examples are use the word AI. Okay, because it depends what all fields we are searching in. Either we are searching in title, abstract, or keyword. So if, like say for example, somebody has used the catchy title like AI based system development. Okay, and if you don't use the word AI in your search term, then those paper won't be retrieved. Okay, so that is why we need to search it down, that what all terms we need to select for retrieving the data. Okay, so if you see here, for selecting the terms for tourism, the first example is about the paper which have mentioned some of the influential and the common keywords they found in the journal Tourism Geography. Okay, so these were the common words they have found: tourism development, tourism, tourist destination, tourism management, tourist behavior, ecotourism, mobility, urban tourism. Then another paper they have used that these five terms for extracting the data. Okay, they have used hotel, hospitality, travel, tourism, and tourist. Okay, so they haven't used the tour. Okay, then if you see the another paper, they have used only these three keywords. What those three keywords are: tourist, tourism, mobility. Then if you see in the this another example, they have used different words like hospitality, tourism, food and beverages, then tourist guiding, and cultural heritage, like that. Okay, so by doing this, what we get it, we get to know that okay, these kind of words we can use for extracting the data, for getting the understanding of for that particular research area. Okay, so that is why we need to do a kind of a pilot research before doing this study. Okay, because your whole study is based on this selection of terms. If your terms are like covering the most part of your particular domain, you will get the more good results. Okay, so based on this particular analysis, what we did, we come to the conclusion these words for the representing the research on AI, and then we have used these many words for representing the tourism side. Now if you see in like this first example and in the second example, these are exactly the same terms are there. Okay, so what exactly we are saying here, that search all the documents where you will find the artificial intelligence, AI, machine intelligence, all these terms, and this tourism, tourist, travel, hotel, hospitality. Okay, it representing that any of the words should be from this red part, should be in the that particular fields, and then any of the word can be from this blue part. Okay, so these two terms should be there in that particular field, whatever the field we will be selecting. Okay, so if you see in the second this terms, we are representing in a different way. Okay, so if you see here in this tourism, tourist, and then tour, the common word is tour. Okay, so what we are using here is that tour, then star. So what this star means that anything, So it can be tourism, it can be tourist, it can be tourist. Okay, so that is why we are representing it as a tour. Okay, so this again you will get an idea of this when you will be like have some expertise on your area, or maybe you consult with the librarians or the published research. Okay, that is why you will come to know that okay, there might be the possibility that some of the research paper have used not tourist, they have used tourist, plural is there. Okay, or maybe some other form of that particular word. So that is why the selection of term is become very important step for doing the research assessment. Okay, and if you have noticed here that we have mentioned or and then and. So what exactly these or and are? These are the Boolean operator we have already discussed. So or means that either from this one. Okay, but and means the mandatory one. Okay, so if we represent this, so when we talk about or, it is either this one or this one. But when we talk about and, it is this one. Okay, this mandatory part, this is and. Okay, so our step 2 is done. So the very first step what we have done is the selection of database. So we have selected the scopus, and then at the second step we have selected the terms. So how we have selected the terms? We have reviewed the already published research on AI, and then on the tourism, and then we found that okay, these words we can use for doing our the assessments. Okay, then at the third step, we will be taking up as searching the title, abstract and keyword. We will be searching not only on title, we will search all the three these fields. Okay. Then at step 4, what we will be doing? We will be putting all these terms into that our databases, and then whatever the results we will get, we will put it the some filtration. Okay, so first let's move to the scopus, and then just we'll simply put this word, and let's see how many number of results we get it. Okay, so let's see on scopus that if we do these 3 steps. So this is a the interface of scopus. So I am moving to the advanced document search, and I am simply pasting it this query. Okay, so this is the query I have already made it. So what exactly it is representing? So these terms search in title, abstract and keyword, and then these terms search in title, abstract and keyword. Okay, so this is what our focus is. So if we put the search, so we got the number of results to 15,449. Let's now put some conditions on these results so that we can do our analysis. So now we will be first doing the filtration based on the year. So let's take it to 1990 and this to 2023. Okay, and so now our results are 14,673. Earlier it was 15,000. So now we will put more conditions, like we want to consider the document type with conference paper, article, conference review, book chapter, review, then book, and then go to the data paper. Okay, so now we want to restrict the old documents to the language English. So we'll put the English language filter, and then we'll go to the another filter called it as publication stage. We will not be considering the documents which are in the press. We will be only considering the document which are the finally published. Okay, so we'll put this filter, and so we got our data. So now what we will do, we will extract this data. So how we will extract? We'll click on select all, and then we'll click on export option, and it will give us the multiple options are there. We'll going with CSV, and like there is a limit of 20,000 download, and our results are within those 20,000. So we can extract these details. So currently we are going with these details. Okay, now if we put export, you see here this option will come, exporting these 13,950 documents, and depending on the speed it will take some time. So in the meantime, until this data is downloaded, let's open our R Studio. So how we will open the R Studio? So either if you have that icon on your desktop, you can just double click on that icon, or you may go to this here and then you can just type in down to R Studio and open your R Studio. Okay. And now we will doing the analysis on this extracted data. Okay. This is the interface of R Studio, and we will be doing the analysis step by step, and I'll be providing this whole code on our GitHub repository. So you can access that code and then you can start your analysis. So as soon as this data is downloaded, it will show this option here that your CSV file was successfully exported, and it will be downloaded in your download directory. Okay. So it is downloaded here. Now let's move to our R Studio. So the very first thing for doing the analysis in R, what we will do, we just check that what directory we are in. So how we will check the directory? Using the function get wd. So we'll call this function, and it shows that my directory is user del document. So it is a document directory. So now I have two options. Either I change the directory to downloads because my data is downloaded in download directory, or I move that data to the document directory. Okay. So what I will do, I will not change the directory. How we will change the directory? We can change the directory using the function set wd. So I'll just copy that whole data into the document directory so that we can easily access that. Okay. But if you don't want to change the directory or don't want to copy that data to the current directory, what exactly you do? You can give the whole path whenever you are calling that data. Okay. Whenever you are doing the analysis, I don't recommend that you give the whole path. Either you copy that data into that current directory or change your current directory. Okay. That makes the task easier. Okay. Our data, the file name, as soon as you download, it will be named as Scopus. So I have copied this data into our document directory. Now how we will read the data? So to read the data, there is a function we will be using read.csv, because our file is in the CSV file. And if I don't write the file name here, as soon as I type scope, oh, I haven't copied that file. So first let us copy that file. So I just copy and then I paste it here. This is my data, and I'll import it into an object called df case. So if I run this, so my data is imported in an object called df case. So after importing the data, what we will do, we'll just see what exactly the data is, how it look like. So what function we will use for viewing the data? It's the view function. So I'll call this view function and just name our object, and as soon as I run it, so this is my data. If you see here, so these 13,950 entries are there, and all that data is here. Okay. Now let us first summarize that our data set, what exactly the data we have. Okay. So to summarize the data, what we will do, we'll use the summary function. So summary df case. So this summary gives us the output that these are the columns are there and their details. So the starting year is 1990 and the last year is 2023. Okay. So we got this. So now move to our first analysis, which is exactly year wise productivity. Okay. So how we will do that? So let's start it. So our data, where it is? Our data is that in year. So and those year will be like 2022, 2021, 2020 to 1990. Okay. So and whenever we are doing the analysis, we need to know that what exactly that column name is there, because we have lot many columns and we don't have to put operations on whole of the data, only on the specific column. So how we will check the column name? The best thing is that just we'll put our object name where data is stored and we'll put the dollar sign. As soon as we'll put the dollar sign, it will display all those columns. Okay, so one is that way. So let us see if we write dollar. So these are the column name are displayed, and our data for this analysis is year. We got it here. Another way is to check the column names, and how we will check the column name using the function col names. So we can just simply use that col names and df. So these are the columns in our particular data set. So if you see here, authors are there, authors ID is there, year is there. So now we need to do the analysis on year, and we need to know that how exactly the occurrence of that year is there in that data set. Okay, and for that what we will do, we will use the function called table, because table will count the like frequency of 2022, 2021, 2019. Okay, so if we do like this, now the output of this is 1990 11 publications, 1991 14 publications, 17 publications. Okay, so this is what exactly it is representing. Okay, so now the output of this table function will convert it into a data frame. So how we will convert it into a data frame? Using the function called data dot frame. So this is how we will create our data frame, and we'll assign to a new object called df case year. Okay, so this df case year is only having the data related to year. Okay, so what exactly we have done, we have our whole data is in the object df case, but we are taking up the df case year so that we won't be like confused on the whole data. Okay, so now we have to do analysis on df case year. Okay, what will be the column names of this df case here? Okay, so I request you to stop the video here and just guess without using this R Studio that what should be the column name. We have used table function many times. Okay, so the column names for df case here will be where and freq. Okay, let's see if it is that only. So if I do like this, it's where one and freq. So where one is the those years and the is the frequency. So if I just see my data, okay. So these are the 1990 year is there, then the frequency. So what frequency means here is that in 1990 there are 11 publications are published related to this area. Okay, and in 1991 14s are there. Okay. Now if you see here, we have this year, then this the number of publication. Now we want to have the cumulative sum. So what function we will be using the for cumulative function? We have discussed its cum sum. So let's do one more analysis of cum sum. So the cum sum will be on this part. Okay, because we have to make the cumulative sum of this. So we'll call df case year and dollar. As soon as we'll write dollar, it will give us the column name. So we are going with this. So it is showing here 11, 25, 42, 11, then 14 plus 11, 25, then this. Okay. So what we will do, this is our existing data set is there for our year analysis. So year is there, frequency is there. Now we want to attach this our cumulative sum to this df case year. Okay, so what we will do, we will just call that object and then dollar that column name and assign this output. Okay, how we will do that? So this is our object df case year that have the year data. Then the cumulative frequency, I am naming it as cu freq, and then output of this. Okay, so this I am assigning to this column. Okay, so as soon as you see this, It is done. Now if you notice here, there is a one good thing you need to see is that if you see here, the column is attached to this data. Okay, so to see that, you don't have to call view function. This is already viewed in a new tab, and now to see that, you don't have to call this function view. Okay, so every time whenever like you attach the column or you do any operations, this data will be operated. Okay, so any times like you change this column or you put any of the operations or you attach extra column, this data is also modified. Okay, so this is one time you just call this data, and whenever you are doing the analysis on this data or you're putting some extra columns or you're changing the value, it will be updated dynamically. Okay, so this is not required, but like it's a good practice that whenever you are doing any analysis, you're attaching the data in the existing data frame, you just see it, okay, whether those changes have been made. Now another thing what we want to have is here is that if you see here, we got our year, number of publication, cumulative number of publication, then we want to have percentage. Okay, so percentage of documents, total number of documents are 13,950. So out of those 13,950, what percentage of documents are published in that year? Okay, so how we will calculate? So for that we'll make our formula. So this is our frequency, then divided by total. So this is sum into 100. So this will be our percentage, and I am assigning to a new column. So this is our object df case year, and here I am saying that in df case year object there is new column, that is per frequency. Okay, what exactly? Percentage frequency. I named it as per freq. So now if I run this, it is done. And if you see here, earlier there was 3 columns were there, now this column is also attached. Okay, and my value is there. So if you see here that after decimal there are like values are there for different places. Okay, but we want to restrict to either 2 places or 3 places. How we will do that? So whenever we do it, these things, what we call it as doing some rounding, we are doing rounding things. So the same thing, but we have to do it here also. The function name should be round only. So the function name is round. This is a practice what we do every time, that whenever we are using the function, use this question mark and that round. We want to see that what exactly it do and how we have to call it. Okay, so if we do like this, so all the things will come on the this quadrant help manual, but you see that how we have to call it. So here we want to give that our column where we want to round it off, and then 2 places. Okay, we want to round to 2 places. Okay, and we'll assign to the existing that column. Okay, so if you see here, these are the things. So until now we have seen that whenever we have added a column, the column is attached. Okay, but we haven't changed these values. Okay, we haven't put any operations. Now if we do like this, so these values are changed. Okay, it is done dynamically. Okay, now our this annual productivity is done. Now we want to see the distribution of citations. So let's do that analysis also. So this was our data set only for the year analysis. Okay, now we can save this data into a CSV file and export it, and whatever the document we are writing on, we can just simply paste this table. Okay, so now for doing the analysis on citations, we need to go to the our original data set. What exactly our original data set was? DF case, where we have imported the data. So now we'll call that data, and under that data we need to see that column where the citation data is there. How we will do that? So there are 2 options. The first is like you put the dollar sign, it will show you all column name, or the second is the see the column names. Okay, so I'll just put the dollar here and it will show the all options. So my citation related data will be on this column, cited by. This we have already discussed in our lecture that for doing this we will use the function aggregate. So what exactly aggregate does is that cited by on this data is our df case, original data. Okay, so don't use the data what we have used for df case year, that is for only the year publication analysis. Okay, now we are going for citations. So this is our data set, and then under which we are using the argument sum of this aggregate function. So if I do like this, and now if I see the output of this, okay, so the citations of every year is calculated. Now this analysis is done. So now we will need to present this citations distribution into our earlier that year and publication distribution, so that we can present the tabular in a good way. What we will do, so this is our df case year data was there, under which we are declaring a new column, that citation, and whatever this value is there for cited by, we need to assign to that column. Okay, so if I do like this, now if you see here, automatically the citations are also came here. Okay, so now this is our tabular data is there. So earlier we have done analysis on publications up to here, like year wise publications, and now we have also added the year wise citations also. Okay, so now we want to see the citations per paper, what exactly the number of citations are there for per paper. So what exactly we will do, like number of citations divided by the number of paper, we just simply call this that on that year the citations are there and divided by number of papers. Okay, so this free is the number of publications. So if I do like this, so these are my number of citations per paper. If you see here, we have 11 publications and then citations are 515. So the CPP is 46.81. So what exactly it represent? It represent that at an average 46.81 citations are received by each of the paper published in the year 1990. Okay, citations can't be in decimal because it's like either 1, 2, 3. There is no such thing like a paper has received 1.5 citations. So let's move round it off, and in the earlier cases we have rounded to 2 decimal point, but now what we will do, we will do the rounding to nearest number. Okay, so if we do like this, so they have been rounding to nearest numbers. So this is our CPP. This is our complete table is done, where we are representing the year in a one column, then the number of publications, then we are also showing the like cumulative frequency, then percentage, then citations and the citations per paper. Okay, the whole table can be put out in documents, and then we can give a write up like these were the trends are there, but this tabular data doesn't explain the story itself. Okay, so we will visualize this data so that everyone can understand that what exactly the trends of publication on this area is there. We will plot it. We have a function called plot, and we can check using question mark about this plot. So now if we do plot this, so this is our plot. If you see on my right hand side, this is my plot, because our data set is in those years are in the factor. Okay, because that table function consider the data in factors, so we will convert those factor to numeric and then we'll present our analysis. Okay, so this is our this year data, so we'll convert it to numeric. So how we are converting to numeric? So the factor data we are first converting into character and then into numeric way. Okay, if we do our analysis, so now if we call our this plot function, let's see what output we get. So a line is drawn, and also like if I don't write this these dots are there. Okay, if you see earlier, these were there, but now this is there. Now what this type equal to L means is that it's a line. Okay, we need a line, and this is the width of line. Okay, so this I am giving 2, we can give it to 5 also. Let's see whether the any changes are done. I see, like, why this plus is coming. This plus is saying that something is missing. What exactly we missed? We missed here this 5 and this. Okay, and if I have to, let just first escape from it, and now so now we have the more thick line. Here you have to just it's a kind of a tip for you, that whenever you have a big kind of a command is there. Okay, sometimes whenever like we are calling in this way, like we are selecting it and then we are running it, sometimes we missed it, like the way I have missed here. So the another thing is that what you can do, you can just bring the cursor here, you just click here and then just give the run command. Okay, it will automatically run this. So either you do like this or you do like this, it's the same thing. Okay, now move to the more part. This is our initial graph. Now we want to add some values to this, so that whenever somebody sees this graph, they can understand that what exactly the point is there, where the value is went to exponential and what was the minimum value. Okay, and also we can add some color also. This is how we call it, like this is our where one, this is our x-axis, this is our y-axis, this is type. What we are saying is the type is line, then the width of the line, color is I am saying red. So you can give the hexadecimal code or maybe the names of the colors. Then this the x lab is the x label, what label should be given. So if you see here, the currently the x label is this. Okay, whatever the our name of the object, it has taken that only. And the y lab, we want to have this publication, and in the this main is the title of that plot. Okay, so the title of plot is the annual distribution of publication, I am giving it. So if I run this, now if you see here, so earlier in our plot, it was like these labels were there, then color of this and thickness also. So now the main is also coming, the title of the whole plot is there, then x label, y label, and this red color of line is there. Okay, now we can add points to the line. We can do like this, you can point here. What we are doing is like we are calling that on this line you just point it with blue color. Okay, and what exactly this PCH means is, this PSCH are the symbols. Okay, what symbol you want here. Okay, so like say for example, you want to have a different symbol. Okay, just I'll so if you see earlier there was like a symbol where dot was there, now this other symbols are there. Okay, where you can check these values of these whatever you have to take it here. So you can just do the question mark PCH and you will get the value. So these are like the value of the PCH will be from 0 to 18. Okay, now you want to have only at the selected points. Okay, you don't want to have at all the locations. Okay, so now you want to have only at the selected location. So our data is like this. So now we want to have at these many locations, like first location, then at location 6. So we are selecting it. and then instead, like earlier what we have done is that earlier we didn't mention, we mentioned that on all the points of these where one, okay, but now we are mentioning only on the selected points, okay. So that is why we have to mention here selected one. If I run this, the points are on the selected points of that graph, okay. We want to label also because it generally not representing what exactly that value is. So the on those selected only we want to give the value. So how we will do that? Using that function called text, and if we call it like this, so now this value is there, okay. So what exactly we have done here is that we have called this text function, we have given that, okay, at this particular location, the selected we have already defined, these are the labels, okay, fruc is the label, so these are the labels, and color, so this is a hexadecimal code, and then 0.9 sex size, and then pos. Pos is equal to 2 means the position, whether you want to have at the second position, third or fourth, the value can be 1 2 3 4, top down right left, okay. So if I change to 4, let's see what exactly happen if I change to 4. So see the values are here. If I change to 1, the values are here, okay. So if you see here, so it depends on you that where you want to label it, okay. The another thing is that you want to mention the points only at the selected location, okay. The selected location means where the frequency is maybe like, say for example, you want to keep the points only where publications are more than hundreds, okay. So how you will do that? So it's your practice, just let us know, I'll just sharing this code, but for practice you just think of that how you will do to give a points on particular point, say for example maybe more than 1000 publications, okay. So these are the two lines of things you have to do the same way whatever we have done this, but you just give a practice without using this. Now the whole this plot is though it's representing, but we can make it more beautiful, okay. How we can do that? Like say for example in this particular plot, if we see here, if we can make it like in this way that we can change the color up to here, then up to here, and then here, okay, so that we can show the transition, okay. These were the initial year when the publications were like quite steadily growing, then at this was the year then exponentially grown, and now again the those increasing of the documents are still in the steady way, okay. So how we will do that? To do that we need to have this package called plot tricks. So we'll call it this library. If you don't have the installed this package, how you will do that? So there are two way or maybe three way. You can like call from this interface or using the command, or you can either from local downloads. So I just call it, I have already installed. Now we just give the margins. So now what we want to do is like we want to cut this whole plot in three parts. One part, then two part, and then third part. So how we will do that? So to do that we select some colors. So here we are selecting some colors. So we are taking this color, then this color, and this color, okay. Now to visualize that our data in that plot, we need to call this function called CL plot. So CL plot is a function in the package plot tricks, and the calling of this CL plot is the same way what we have called in plot. Only thing is that we will add some more arguments, okay. So this is our where one is this year, then this is the fruit, okay, then this is the main, then I am saying that width of the line I am giving it to 5. Then this is very important, what we are mentioning here is that 93 and 404, what exactly mean is here that we are putting the cut line at the 93rd location and the 404, okay, where the frequency is 93 and the 404, because these are the year which if you see here in our data 93, after 93 there was some changes were there, exponential growth was there, and after 404 like increasing those things are there, okay. So I am taking these two level, but if you want to have only one level at like 404, like up to 404, and then from 404 to the last level. Okay, then I'm calling the colors, and then sockets, and then xlab and ylab means what are the axes, and those things are there. So if I call this, so our initial task is done. What we want is that there should be cuts on that line, but our y-axis and x-axis is not there, and we want to add some labels also. So now we will do that. So this is our axis. So this axis one, it is calling for x-axis, and what I am saying is that where one whatever the year are there, we want to call it for our x-axis. So if I run this, so x-axis is done, then y-axis. So why I am taking this value to 0 to 2500? Okay, because our maximum number of publications are here 2493. So that is why I have taken is this value is there. Here I mentioned just the those years. Okay, and here I mentioned the sequence. Okay, this is what like the way you can call it in this function, and that is the beauty that in different way you can call it the values of that particular function. Okay, so we can call it here also, like under instead of this df case year $var1, I can also use this sequence from 1990 like to this 2023. Okay, so you just give a try by doing that. This is done. So if you see our earlier plot, in earlier plot we do have this only, we don't have the x-axis and y-axis. Now we have x-axis, y-axis, label are also there, and the title. Now we want to add legend also. So what exactly legend? Add the extra information, what exactly this line represent. This line is representing this year, then this year. So we need to like add that legend. So how we will add the legend? So in legend there are like three things we have to provide. Like top is the location where exactly we want to have this legend, then the value, like those colors value, that what exactly dot representing, and the colors. Okay, so if I call this, so it is showing that this particular area is from 1990 to 2003, then is 2003 to 2016, and in the finally we are from 2016 to 2023. Okay, now like instead of this location you want to have the legend at maybe at this location or maybe at specific location. Okay, so that you have to define it here. Okay, so you can do that way also, because the legend have only some option like top, down, bottom, like that, but we want to have at the specific location. So this what exactly x 1992 is. So this is x-axis, so x-axis this value, y-axis this value, you put the legend here, rest thing is same. Okay, if I call like this, so now my legend is here. Okay, now what we will do, the way we have done the labeling in our plot function, the way we will do the labeling. So these are the labels, and if I do like this, labels are done. So here you can select any color. So I have selected the black color, but it depends like what are the color you want to have. First thing is done, then you can extract this plot as a, whether you want to save it as image or save it as a PDF. While doing the save as image, it will ask you the some of the options, like what should be the width and the height. And also you notice that here it is exporting this whole plot. Okay, so whenever you are doing like this is like I have already called the legend, and on above I have put the one more legend. Okay, so you need to clean it, and then you have to rerun this first the plot and then the legend. Okay, so you will be calling one legend either this way or that way. Okay, so like we'll just, I'll show you, I'll just close this. This is done. Then this is our x-axis, y-axis, legend. I am not taking this one, I'm taking this one, and then this. Okay, so now we can export this either by save as image or PDF, whatever the option you want. Okay, Now we'll move to our another analysis where we want to see the top sources of the publications. Okay, what exactly the top sources are there where the maximum number of documents are published. Okay, so the first thing what we have to do is we need to know the column name. So for column name we have that like either by dollar or by using the column names, or maybe we can see that this is our column where our those sources are there. So now we have to do the analysis on this. DF case here was the object which is storing our year and the publications and citations. Now we have to do it our analysis on source. Okay, so to do the analysis for sources we need to go our original object which was is DF case. Okay, we'll use that table function again, and if we do table of this source title, it will give us the count like what are the maximum number of publications are published in that particular. So if we do call the table function, it give us the like these were the sources are there and it has occurred this many times. Okay, so now what I am doing is there that I am just running this table on this source title and making it as a data frame. Okay, because table function just give the source and the number, so I am making it as a data frame as var1 and the freq. So and I am storing it as in new object df dat source. Okay, so it exactly df our data source. Okay, but you can give any other name as I like. I am using df case, but you can use the different name also. Okay, so if I do like this, that thing is done. Then I am just ordering it to like decreasing order. I don't want to see like all those things. I want to see in decreasing order. Like what are the sources which have the maximum number of publications. So if I do like this, now it will not automatically show that in tab because we haven't called this one. Okay, we need to call this first. So if I run this, okay, so these are the our top sources are there. So this was the source lecture notes in computer science which have the 947 publication or related to this area. So this is how you can identify the prolific sources related to this area. Or maybe like if you want to see only 10 sources, you don't want to see this whole list. Okay, so how you will do that? You can call this head function, and under this head function you can mention that okay, I want to see only 10 only. Okay, so if I do like this, okay, so only 10 will be displayed. Okay, or maybe you want to see the sources only which are having the 100 or more than 100 publications. Okay, so that also you can do using the subset function. So how we will do that? So if we call like this, so this is subset function, and under subset what we are saying that this is my object data is there under which wherever frequency is either 100 or more than 100, you select only those. If I do like this, and now if I see our df100, so this is the thing. Okay, and now you can export this data as either CSV file, and then you can put in your document where you are putting all those analysis. Okay, so to do that we can use this function write.csv. So now we next move to our another analysis where we want to see the authorship analysis. So in authorship analysis, we want to see that number of publication which are single authored or maybe double authored or multi authors are there. So how we will do that? So to do that, we need to first see our column name where data is there. So data is in our this column. So I just delete this. So this is our original data object, and this is our data is there. This is the one where our author's data is there. We need to do our analysis on this particular column. And also we need to see this all authorship pattern with the year basis. Okay, so in maybe in this year how was the trends were there of single authored or multi authored papers are there. Okay, so we need another column which is a year column. So because we need to present the data with respect to the year, so we will make our another object where we'll have the year column and the author column. Okay, so now we'll call it as this here, the data dot frame year equal to df case year. So this is our year data and this is our authors data. Okay, now if you have noticed here that until now whenever we have created a data frame, we didn't mention this year equal to. Okay, and if you remember that I have discussed that whenever we are creating a data frame, the data frame just takes that this particular as the column name. Okay, but we can use in this way that we can define our column name that it should be year only. We don't give this column name here, and just if we create a data frame on this, then it will take that as a this as a column name, and then we have to change those column names as a next command. Okay, so to do that, the best way is that we declare here itself that we need to create a data frame, and our first column is year, where the value will come on this particular column of that data, and then this is our another column which is named as it as author, and the value will be come from this df case dot dollar authors. Okay, so if I run this, now we'll see. Okay, so if you see here, column name is year author. So this is why, because it makes task our easier. Okay, but you give a try that without giving this year and without this whether it is giving the same column name or the different column name. Please let us know in the discussion forum. Okay, now let us see our data set. So if you see this particular first value of our author column data set, so it is in a text data. Okay, so there is no any provision is there so that we can identify that this is like two author are there in this and then three authors are there. So we need to do some kind of analysis on that. Okay, how we will do that? So if you remember in the week 9 we have discussed about the in the text 9 some pattern matching. So we if we are able to identify some pattern in this, we can easily solve this problem. Okay, if you see here these authors name, can you identify some patterns? So this is one author name is there, then this is another author name, and this is another author name. So one pattern is that I can see is that all these author name are separated by semicolon. Okay, so this is one author, this is second author, this is third author. Whenever we are extracting the data, so either you are extracting the data from Scopus or Web of Science, they all the author names are separated by semicolon. So if in somehow we can count the occurrence of semicolon, we can solve this problem, that counting the number of authors of that publication. Let's do that. So to count the number of these occurrence of semicolon in our this column, what we need to do, we have to use the package called stringer. If you don't have installed this package, you can install it, and after installing it, just call this library. And in this there is a like different functions are there. So one function is like this str extract. As soon as you write str extract, it's saying that you need to provide the string and the pattern, that this is the pattern based on which it will extract that particular pattern from that string. Okay, so if we do like this, so semicolon it has extracted, that means this particular data set has semicolons presence. Okay, but in the same way, if we go with the title of the paper, so if we call it like this, and let's see whether title has semicolon. Na means there is no semicolon exist in the title. Okay, now what we need to do, we need to count the presence of the semicolon or whatever the pattern is there. So this particular package has another function called str count, that exactly count that presence of that pattern. Okay, how many times that pattern has been present in that particular string. Okay, so for that we need to call it like this is our data set, our first data set of authors, and then this is the pattern. So if I do like this, it gives the output 2, but our number of authors are 3. If you see here, our number of authors are 3. So what we can do is, so whatever the output is there, if we can add +1, it will be number of authors of that particular publications. So our problem is solved. So this is our presence of semicolon, and if I add +1, it will be number of authors. Okay. So this was our data set. DF case auth has the year and authors, and now what we will do, we'll count the presence of all semicolon and we'll add the +1. Okay, and if I do like this, and what I am doing here is I am attaching one extra column which is storing this author count. If I do like this, so in 2023 one paper has been published by these authors, and these authors are 3. So here the 3 authors are there, here 4 authors are there. Okay, so our problem is solved. We have counted the number of authors in that particular paper. Now we need to do some more analysis, that number of single authored paper, number of double authored paper, number of triple authored paper, or number of more than 3 authored paper. Okay, so how we will do that? So for counting the occurrence, we have used this function table many times. So we'll use that only. So let us see if we do like this. So you can see that there are like single authored paper are there in whole data set is 1887. Then there are like 2928 publications are there which are authored by 2 authors. All these things are there, and you can see here that interesting pattern, that there are some papers are there which have been authored by more than 100 authors. Okay, if you see, there are like 3 papers are there, out of which one is authored by 107 authored, then 113 authored, and then 163. Okay, so from here you can inference that one of the paper has maximum number of authors to 163. Okay, now we'll count these number of single occurrence, number of double occurrence. So how we will do that? We can use this sum function, because we want to have only the single authored paper. Okay, so if we use here table, it has give us the whole data like single author, double author, triple author, but now we want to see only on the single authored paper. So what exactly we are doing here is that, so this is our data set, and here I am seeing that equal to means wherever the occurrence of 1 is there, exactly 1. Okay, and you count it and make it as a sum. Okay, and the same way 2, that 2 means there are double author paper is there, then 3 triple author, and more than 3. Okay, or you may want to see the number of publication which are authored by more than 100 authors. Okay, so how you will do that? Simply instead of those equal to, you can just simply give the this greater than and equal to sign. So these are the 3 publications you see. So this is one kind of analysis is done, but now we want to visualize it in a better way, so that we can visualize that in this particular year these many documents are authored by a single author, these many by double authored, maybe triple, and more than 3 authors. Okay, so for that kind of manipulation we need to use another package called dplyr, and we need to install it. How we will use that? First we'll call this library. So what I am saying, that this is our raw data set is there of authorship, and whatever the output of this, it will be assigned to this. So I am saying this is my data set, it mutate fifth class in this. Okay, so what I am saying in this particular data set, one more column should be added. So what these cases are when there is a count of only one author. Okay, In the second case, if it is there are like two authors are there, then three authors are there, and then more than three authors are there. Okay, so if I do like this, now if you see here, so a new column is added where three authors are there, then four authors more than three. So the whole data set we are making it in the four groups. So one group is the number of publication which are in by single author, then another group which have the number of publication by two author, then the third group has the number of authors are three, and in the fourth group where more than three authors are there. So it can be 4, it can be 10, it can be 20. Okay, now what we will do, we will just count the number of these authored publications. Okay, so how we will do that, we'll again count the occurrence of one author, occurrence of two author. So for that we'll use this table function. Until now we have used only one column in a table function. Now we can also use the two column also in table. Okay, so let's see that how we will do that. So this is our year, and under year we have fruit class. So year wise we are checking it. Okay, so if we do like this table, so year wise author details are there. For 1990 more than three authors, one author details are there. Okay, and we'll assign to an object called as final analysis. Okay, now we will just first see what exactly it is. So the whole data we have, like, see these 136 entries, because our year data is for 34 years from 1990 to 2023. So it counted the all four group value for the each year. So what exactly the occurrence of more than three authors for 1990, what exactly the occurrence of three authors for 1990, what exactly the occurrence of double author for 1990, what exactly the occurrence of single author for 1990. So this is, they are counted for all the 34 years. That is why it is showing here 136. Okay, 34 into 4, it will be 136. If we see, come down here, so for 1990 one author. Okay, so this is how this is done. Year wise we have calculated. Okay, now we'll make it as a data frame, and we can export this data in a CSV file for our like analysis if we want to present this table only. Okay, so the way I have discussed about the line plot. Okay, so we have the whole data in tabular form about the year wise productivity, but with the help of cut line plot it gives us the more understanding about that how the trends are going on. Okay, so in the similar way, if we can have some kind of a visualization, that will be more understanding of that data. Okay, so that is why we'll make some graph for this. Okay, so whatever like this is there, this whole table will be like not that kind of understandable, but we can make it as a good graph. So for this kind of a like data, we will be having the stacked bar plot. So what this stacked bar plot is, that we will be having the heights of each year, and all those height we will be mentioning that for this height these many are the more than three authors publication, these are the three authors publication, these are the two authors publication, and these are the single author publication. Okay, so for that we will be requiring another package called ggplot2, and this is a very popular package for visualizing any data in R. Call this library, and then it has some arguments. So there are like different arguments, the same the arguments what it has for cl plot. So we are telling that this is our data, and then it should be filled with, these are the variable frequency, then it's a stack, then the title, authorship pattern, x axis, y axis. Okay, and where should be legend will be pasted. Okay, so if I just run this, okay, this is a better way of representing our data, because if you see like this was our analysis. Okay, this is showing in this 136 entry, but what we can do is we can have year here, and then in the column we can have more than 3 authors, then 3 authors, 2 authors, single authors, and then we can present the table. But that table won't be in that kind of a sense that it describes the whole story. Okay, but if you see this graph, anyone can understand that okay, and these heights are explaining that kinds of multi-authors papers are published on this domain. Okay, and then you can export this as a whatever the format you want, whether it is the image or a PDF. Also you can like if you see here, you can just add the data label also here. So that's your practice. Just let us know in the discussion forum if you are able to add the data labels here, or you are not able to do that. Will help you maybe in the discussion forum itself, or maybe in the live session. Okay, so now let us discuss our last part of this case study what we have thought of. So we have done the annual production, then citations, then we have seen the plots also for that annual distribution of the publication. We have also seen the how we will be doing this, that authorship analysis. Okay, so to do identify the core sources, we will be following this Bradford law. So what exactly Bradford law does is, Bradford law identify the core zone of the sources. Okay, what exactly the core zone of sources are there, that particular domain or area. Okay, so we'll do that. So to do the Bradford analysis in R, there is a package called bibliometrics. We can install it and then we can call it library. But we won't be calling it directly as it's an open source. I have discussed in the previous lecture. So what we will be doing, we'll use the code of this Bradford, how they have written the function that is available in the on the GitHub repository. So whether you are doing the analysis by calling that Bradford function directly from that package, or you are using the code from the that particular function and then you are making it some changes, in both the cases you must cite your that package bibliometrics. Okay, because the authors have developed this whole code after spending huge amount of time, and they have made this whole code freely available. Okay, so whenever you do use this any of the package or this R, you must cite on those your analysis or wherever, like if you are making it report or anything else. So this is the code of this Bradford. So if you see here, this is the whole function. Okay, so whenever you are like just using any code, you need to know what exactly the argument they are using, what value they are using it. Okay, so this is a function. So if you see here, the Bradford function is written for single argument. Okay, so that single argument is M. What M is that? M is a data frame which has many objects, but it has different column name. If you see our DF case, it has source.title, but if you see the code, it has the column name SO. If you don't change this column name to SO, or if you are using this code, it will show the error. Okay, it won't work. Okay, either you change this code based on this your column name, whatever the data you have, or you change the column name of your data set, then it will be easier for you. Okay, so that is why the beauty of this open source is that you can see the whole code, what exactly the approach is. Okay, how the Bradford law is calculated. Okay, so what I'll do, I'll just change the column name to SO. So how I will do that? So this is my data is there in DF case object, and source title is where my sources are there, because while identifying the core sources, the only requirement I have is the those sources. Okay, I need to identify the core sources. I don't need any kind of other column data. Okay, so I change it to SO. If I do like this, now this is my function to calculate the Bradford law. So if I run this, so like if I do like here, so it is run. So now this is my function is there, new Bradford. So this is what exactly the code of bibliometrics package is there. Okay, only I have changed the name and I have changed my column name in my data. Okay, and I named it as new Bradford. And here I'm giving the DF case. So now this DF case is only compatible with this Bradford analysis. Okay, because this DF case has one column as per this function, whatever we have taken it from bibliometrics package. Okay, it has SO, but we haven't changed the other column name. So whenever you are doing like in this way, you see the code what exactly the column name they are referring it. Okay, so they have also go for one function called that convert to DF. So before doing any analysis, you can convert that data frame as per the requirement of bibliometrics package. But just for your understanding and just for exploring the new things, you go in this way so that you get the understanding how things are going on. Okay, so I'll call this. So this is my new function and this is my object where it is, and I'll assign to new bread results. Now I'll just call this, whatever the output of this, I'll call this. So if you use the existing code without any changes, this color will not be changed, but I have changed the code here. So this was the same code which I discussed in the earlier lectures about how we can customize this code as per our requirement. These are the core sources, and you can see, and then you can also change the other colors also. Okay, and here you will get all the details of zone 1, zone 2 and zone 3 of that particular data set. Okay, and this is how we can do the analysis of our data set in R. And in this particular lectures, we have discussed about a case study on a domain where we have discussed about some of the analysis. And in the next lecture, I'll discuss about the case study of an author and how different analysis there we can do using R. See you in the next lecture. Thank you.